Hello everyone, this is the Quibble team. We want to go over some new concepts made possible by the Quible Network. Quibble is designed to facilitate real-time access lists. This is normally done with Merkle trees at the moment, so first we're going to review how Merkle-based access lists work. Then we're going to recap some of the limitations involved in using this approach. Then we'll introduce a similar but more useful data structure that we call the Quirkle, made possible by the Quible Network. Let's get started by looking at a prime example where it is common to use a Merkle tree for an access list. In this example, we have a seller and 3 buyers, and the seller only wants to grant these 3 buyers access to their next sale. The first step here is for the seller to obtain the wallet addresses of each buyer and construct a Merkle tree. Next, the seller needs to publicize the leaves from the tree and find some way to share them with the buyers. This is usually done by storing them in a database, making them available for retrieval later. Now the seller is launching their sale and needs to configure an access list. This is accomplished by obtaining the root from their tree and storing it in the sale contract. Now that the sale is live, buyers are ready to purchase from the sale contract. This is done by calling the sale contract and passing the Merkle root to the contract. During the call, the contract can now verify the buyer's proof against the configured Merkle root. Upon completing the verification, the contract mints the NFT for the buyer, and this process repeats for each buyer participating in the sale. Now, let's look at the limitations of this approach. One key problem is that the leaves must be stored by the seller or the buyers. When you want to add or remove members, it becomes a headache because you need to share the leaves again. The other pain point here is that replacing the root involves committing a new transaction on the chain hosting the sale, which can impart further gas costs. Now that we've covered the limitations, we want to introduce a new concept, the Quirkle, which is an alternative made possible by the Quible Network. To demonstrate the difference in design, we'll look at the same example of an NFT seller. This time, the seller starts by connecting to the Quible Network and then authoring a Quirkle. Now the seller can add the buyer's addresses to the Quirkle to indicate that they have access to the sale. Next, we see the same steps as we did in the Merkle tree, where the seller configured the sale by obtaining the root, in this case the Quirkle root, and storing it in the sale contract in the same manner. Now we've diverged a little from the first example, because the seller didn't need to store the proofs anywhere or share them with the buyers. This is because the Quible Network generated proofs on demand, making your implementation easier. Now let's see this in action. When a buyer begins to purchase, they must first acquire the proof by connecting to the Quible Network and requesting it. This exchange requires no gas. In this design, a Quirkle proof is similar to a JSON web token, where it grants the proof holder access to an application or contract for a limited period of time. Now that the buyer has obtained a proof, they can follow the same steps we saw before by calling the sale contract and passing the proof. When the contract verifies the proof as we saw before, and finally, the contract mints the NFT for the buyer. We can repeat this process for buyer 2. I want to demonstrate a key feature here, where the seller or Quirkle author can update the contents of the Quirkle in real time. Let's say the seller wants to remove this third buyer from the list. To do so, the seller can commit an update with the Quible Network. Now that the buyer is removed from the list, we can see what happens when the third buyer attempts to start the purchasing flow. When the buyer tries to request a proof, they are denied because their address is not included in the Quirkle root. Now that we've demonstrated some key features, let's recap. The Quirkle provides a single, stable root that can be used in multiple places or even on multiple chains. The Quible Network makes it easy to update your Quirkles in real time, without a need to commit to the host chain. Lastly, Quible removes the requirement to store your proofs anywhere, which simplifies your implementation. If this is interesting to you, feel free to check out our white paper. Thank you so much.